equations, were you able to separate the variables? It's a bit of a trick here. Do you have that? Did you get it separated? How can you get the x's and the dx's on one side and the y's and the dy's together on the other side? Anybody have any ideas on how we can rewrite that? Okay, think about it, and we'll go over it in a minute. You need to think exponent rules. That's what I would suggest. Yes. Boom. Got it. Okay, you ready? So what's your answer? I equals X. Do that. Yep. Do not take the log. You don't want to deal with the log of the differential equation. Okay? So how does this separate? Difference of exponents means division, e to the x over e to the y. So what that's equivalent to. So if we multiply e to the y over, you get e to the y and the dy together, e to the x, dx together, integrate, that's e to the y equals e to the x plus c. If I use the fact that 1, 1, then I get e equals e plus c, which means c must be 0. Therefore, e to the y just equals straight up e to the x. If I log both sides, y is x. Yes? Now, if you are a critical thinker, you might think, what the heck is going on? If y equals x, then that seems to imply that dy dx should equal 1. How can they get me this crazy differential equation if the derivative should be 1? It's through substitution of something into itself. Wouldn't you agree that 1 is equal to e to the y over e to the x? Actually, let's go. Wouldn't you agree that 1 equals e to the x over e to the x? Wouldn't you agree? Wouldn't you also agree that if, according to my solution, y is x, so I could replace this guy with an e to the, or this guy with a e to the y if I like, because they're equal, and that's the same. And so it's only by substitution of the original fact into itself that you can get something more complicated. All right, let's go to today's lesson, volume part 4. All right, what are the 3 volumes we use for volumes of revolution? Anybody? Disk. When we do a disk, it's typically the volume is some type of pi r squared, and the height is the differential dx or dy, whatever. Okay? What else? Washer. Volume is pi, big R squared minus little r squared, and again the height is a differential dx or dy. And then shell. The idea is volume is 2 pi times the radius times the height, and the third dimension, the thickness, is a dx or dy. Okay, now all those are still there, and we're going to still use those three. We're going to just change where we revolve it a little bit. I'll talk about that in a second. Let's review one other thing, or a couple other things. If rectangles are done this way, then the thickness of those is delta x. The base is delta x, and when they're made very thin, the rectangles are so thin that delta x becomes more of a dx. So when you see slices go up and down, then the thickness of that pi is dx. You with me? Okay? If the rectangles go this way, then the height is a delta y. And if they're made very thin, then that height becomes more of a infinitesimal d. So when slices go that way, it's y variable of integration. You with me? Yep. All right, last but not least, and this is the most important part for today. Okay? This is going to get hard, and you have to be very careful to make things positive. To make things positive, if you just always do right minus left when you want a horizontal distance, you will always get a positive output, always. And if you do upper minus lower for any vertical distance, you will always get a positive vertical. Right, Jasper? Right. All right. Now then, let me introduce the ideas. Imagine you have the region y equals the square root of x, and y equals 1/2 x, which are designed to meet nicely at what point? 4, 2. Okay? All right. Now then, here's the part that's new. The new part is the axis of revolution. All we've done so far is revolve around the x-axis or the y-axis. Right, Colin? Right, Colin?
Yes.
Right. Today, then, you're going to revolve it around something besides the x and y-axis. For example, if you revolve it around y equal 2, then the reflection might be something like, now think of, it's easier probably to think of, this guy's reflection would be here, and this guy's would be here, and you get this kind of cone type shape. You with me? Now if I use x, then if I draw one representative slice, will that slice go up and down or side to side? What is an x slice look like? Up and down. Okay. So if I draw a slice like this and revolve it around y equals 2, then I will get a washer. All right. Easy enough. I know my approach to washers is pi big R squared minus little r squared d, in this case we're using x, so it's dx thick. Follow? All right, now, here's where the thinking part comes in. What's big R?
1/2x.
Okay, so here's big R, right? Here, yeah? And depending on the slice, it'll be different. Here's big R, here's big R. That is a vertical distance. And therefore you will do upper minus lower. make it positive. What's upper? Here's the upper mark. Here's the upper mark. Here's the upper mark. I asked you again, what's upper?
2.
2. Every time, the upper is 2. Upper is 2, every time, right? The lower. Now, does the lower vary?
Yes.
Yeah, it's tied to the line. So, one more time. What's upper minus lower? 2 minus the line. Okay? I know. You can think of it this way. This total distance is 2. This distance is the line. So this is 2 minus the line, right? All right, let's go the inner radius. The inner radius is here, or a little bit here. Okay, that's the radius of the inner circle. Again, upper minus lower. 2 minus root x. Okay, limits of integration, 0 to 2 or 0 to 4? 0 to 4. Okay, because we're dealing with x. You'll need a calculator. We're not going to do these by hand, although we'll build up to it. For now, we're going to evaluate with our calculator. So get out your calculator. And slap that in your calculator. This will get pretty gross as far as parentheses and calculator mistakes. They're very common, so I strongly recommend you do more than just sit there and wait for somebody to do it for you. You should practice it yourself. Of people that know what they're doing, the most common mistake is forgetting the pi, so make sure you type it in right away. Parentheses. Parentheses are free. Use a lot of them. Minus x squared minus parentheses 2 minus x. Oh, darn it. Squared. Don't forget the squares, obviously. I'm getting 8.3775. All right, cool. Okay, now, like a lot of problems, not all problems, but a lot of problems, you can go 2 different approaches. Remember that in a case like this, if I use x, the slices go this way, and it's one integral, pretty cool with x. If I use y, the slices go this way, it would be one integral. In both cases, they're one integral. The equations are pretty friendly either way, so you could go x or y, right? If I had something that was hideous, like a cube, well, surely I would use x at all costs, and I wouldn't consider using y. So we'll talk about that. But in this case, you could definitely use x or y. So would you do the same volume and the same revolution, but if you're using y, you should get a different method than a washer. So draw it again, do a y slice, and recalculate the volume. The volume should come out the same because it's the same region and the same axis of revolution, just a different approach. Try it with y, talk to your math amigos. We'll go over it in a minute. These are going to take some practice, so don't worry. Learn from your mistakes. That's the most important thing. But don't worry about making mistakes. It'll happen for sure. Okay, let me know if you need some direction or ask questions. Okay. So, yes, so the radius doing, so what's the upper? You're doing, talking about the radius, right? Yeah. So the upper, what's the upper? There's two. Think of it like, let me draw a picture that's bigger so I can. Okay, so imagine this point at 1, all right? We're doing, here. At this slice, what is the radius? Yeah, oops, I didn't draw the scale very well, but yeah, wouldn't you agree the radius is 1, yeah? Okay, what about at this slice at 1.5? It's over here somewhere. Isn't the radius now 1/2? Yeah? So in every time, when we go to find this radius, we can start with 2, take away whatever y is. Isn't this just the distance from the axis up to that slice y? And so this is 2, take away y, or and then it's what? You with me? Okay. Now then. 2 minus y, yes, 2 minus y. Yeah, you're right. 2 minus y. Okay. How are we doing? Obviously, you know the answer, so you should know how it's coming. The question is, can you make the work right? So that's the height is this distance from here to here, yeah? Now that's, I mean, I look at that and I think that's a horizontal distance, so I think right minus left, but, right, do you agree? But it has to be in y terms. So what's the right? Well, the right is some point, the right is always some point on the line in y terms. And the left is always some point on the curve, but in y terms. So you tell me, what's the right answer? Right. Okay. All right, so the idea is, I have practically nobody that I saw going about the wrong method. Most people knew that when you use y, you're looking at a slice like this, and therefore a shell. So that's the first part. Do you know it's a shell? Are we all good there? We understand it's a shell. Okay. We have to understand the radius and the height. The radius is a vertical distance, so we're going to do upper minus lower. So the upper is 2, and it's tempting for students to say, and the lower is the line. And I feel you. I understand. It feels like the lower is the line. But no, because I could also draw the radius over here, and it's the curve. So don't think of the line. Just think of if this was 1, then the radius would be 1. So it's always 2 take away y for the radius. So the radius is 2 minus y. The height is this distance. Now that's a horizontal distance, so the height made positive is right minus left. It feels like every time, maybe this picture is better, every time here, at every one of these, the right is not constant, it's a varying point, and the left is a varying point. Do you agree that every time the right and left are moving? But the right is always a point on the line, and the left is always a point on the curve. So if we're going to do right minus left, we're going to do the line minus the curve, but it has to be in y terms because we're doing dy. So in y terms, the line is 2y and the curve is y squared. That is our integrand. The limits 0 to 4 still, or 0 to 2? 0 to 2. And you'll find when you punch that in correctly, you should get the right answer, the same answer. With me? What, 2 minus y, is that a question, or is that just, okay? So, let me draw this one a little bigger, so here. Would you agree that there is a slice at point 2? Okay? What's the, at that point, what's the radius? How far is the radius then? When the slice is at point 2, what's the radius? 1.8, right? When the slice is at point 9, what's the radius? 2 minus 0.9. So it feels like every time I do a slice, the radius is always the total distance 2, take away whatever y is here, so the radius is always 2 minus whatever the lower distance y is, right? Let's try a little different angle here. If I took this graph, draw it a little higher in this space, and you revolved it around y equal negative 2. Now y equal negative 2 is a horizontal line again, but it's below the region instead of above. So if I want to reflect this lower point, then it's, instead of 2 above the axis of symmetry, it'll be 2 below. And this upper point, which was at positive 2, now positive 2 was 4 units above the axis of symmetry, so I'm going to go 4 units below. So my reflected region looks like that, okay? All right. Now if I were to revolve that, I'd get this kind of empty cup shape. Same deal again. We'll do x together, you'll do y on your own. So if I do x, the slice looks like this, okay? And surely that then represents a washer. Okay? Volume is pi, big R squared minus little r squared dx. And again, the question is, what's big R? What's little r? Big R. Here is big R. It's a vertical distance, so to make it positive, we're going to use upper minus lower. What's upper? Is the upper always the same, or is it varying? It varies. It feels like it's here, now it's a little higher. Okay, so the upper is varying point, but it seems like it's tied to the square root curve, right? What's the lower every time of these segments? Negative 2. So what is big R? Root 2, root x, root 2, root x minus what? Negative 2. So plus 2. Root x minus negative 2. Yes? You would get the same answer because the square is there, but I would definitely take off if that's not true. Negative 2 minus x is a negative, and the square would negate it and erase that mistake, but to me it's a mistake. What about the little r? Here's little r. It's the empty circle inside. So what's little r? 1/2 x minus negative 2. So plus 2. From 0 to 2 or 0 to 4. 0 to 4. Slap that in your calculator for the practice. Then do the same revolution using y. is it? 1/2 1 divided by t x plus t y squared. Did you get 25.1327? All right. Okay, now try and do it with y. Okay. Put it in for y, check it. Anyone want to share their R? Looks like upper minus lower. And upper is varying. And so what'd you call it? Y minus -2. So y plus 2. And then what's the height? That's a horizontal distance. Right minus left. Feels like it's varying on the right, varying on the left. So it's the line minus the curve in y terms. 2y minus y squared. 2y. Do you get the same volume when you put that in? Okay, cool. All right, those are around vertical or horizontal lines. Y equals 2 or -2, whatnot. Let's talk about around a horizontal line. The region is the same region. Is revolved around x equals -2. I didn't give myself enough room. Sure. Okay, x equals -2 is over here, and that is a vertical line. X is always -2. I know it feels like x equals something as a horizontal line, but no. X equals a constant means it doesn't vary horizontally, it's vertical. So if we reflect this region, 2 over on the other side, and we're looking at a region like that, yeah? If I use x as the variable of integration, then that is a slice going up and down. And that slice revolved, and all those slices within each other made cylindrical shells. Sweet. All right. So let's talk about the r and the h that we need to find, given that it's 2 pi out front and a dx. What's the radius? Here's, look at it on your picture. Here's the radius, or here's the radius, or here's the radius. Is that right minus left or upper minus lower? Right minus left. Is the right part varying or constant? Varying. Here's the right, here's the right, here's the right. The left part, is it varying or constant? Constant, okay? And so the question then is, what is the right? Is the right the line, the curve, or just straight up x? Now, isn't it both on the line and on the curve? So don't think so much that. Here, when I'm at this slice at 2, what's the radius? At this slice, what's the radius? 2 to the axis, 2 more to the axis of revolution. What's the radius? 4. Okay. Here, at 3, what's the radius? 3 and 2 is 5. Okay, so it feels like that the radius is always to the axis, or the distance to the axis, which is x, plus 2 more. So right minus left is x minus negative 2, or x plus 2. It's whatever the x is plus 2 more units. You follow? Right? The height. Now, if you're sitting there thinking, what about the curves? Got to use the curves. Yes, you'll use the curves. Just be patient, okay? The curves come in here. The curves come in on the vertical distance, upper minus lower. What's the upper? What's the lower? Root x minus 1/2 x. You're only going to use the curves in one of the two parts, not both. Dx from 0 to 4. Slap that in your calculator. And then do y and see if you can figure out the integral that gives you the same volume but using y as the variable of integration. Square root x. Nope. Did you get 30.1592? Okay, cool. Now try using y. Obviously, should yield the same answer. All right. Hopefully that goes in your calculator and yields the same answer. What did you say for big R? Do you agree it's a washer? Okay. What is big R? Is it 2 minus something, or negative 2 minus something, or something minus negative 2? The right feels like it's some point over here, and the left is negative 2. So, question is, what's the right? Is it x, or the line, or the square root graph? What is it? It's the line in y terms, so 2y minus negative 2 or plus 2. Okay? The inner r is the distance from the square root curve over to the axis of revolution in y terms, so y squared plus 2, and that should yield the same volume. Are we cool? All right. Let's just do this one. I'll let you choose. Use either x or y and find that volume just once. Your choice. In the interest of time, I'll have a little bit of time for questions. Okay, get an answer for me, and we'll compare in a second. Ah. What's your answer? I agree. Let's get it 36.861. Yes? All right. Some say, at least Phil and I agree. Yes, we are. Okay, there you go. That's what I was hoping for. So 36 point, I think it was 186, I just for my memory. If you do X, then do grade shells. Yes, I agree. Good job. What about the R? Here's the R, right minus left. The R, no matter what, is always a constant, 6. The left is a varying point. And then you ask, do I use the curves or the X? And it is X, okay? The curves come in for the heights. The distance between the two curves is a vertical distance. Upper minus lower is root X minus 1/2 X. That's what it looks like in X. If you did in Y, then it's a washer, I believe. I'm just doing this on the fly. Big R, 6 minus the square root curve, so maybe 6 minus y squared minus 6 minus 2y quantity squared dy. That's what it would be in y, I believe, unless I made a mistake. Okay? You get the gist. This takes a lot of practice. Tomorrow we'll do extra practice, and we're done. All right. Questions on set 1. Sorry, I wish I had time for that, but I overestimated. Or underestimated how much time it's going to take. Questions on 93. 2, 6, 22,
10 and 24.
10 and 24. Okay. Now you know how I feel. You get the work. Harder for me to figure out what you're trying to do. All right. I don't have 93 in front of me, so if they're a replacement or something, let me know, please. Is 2 just normal out of the book?
Yes.
Okay. Okie dokie. They give you 1 to 3 is -4, 3 to 4 is 5, 4 to 7 is -7, and 7 to 8 is 3. A, change in position over the time interval 1 to 8. Okay, change in position, is that distance or displacement? It's displacement, okay? If I want to see how I change position, I would want to know, did you move backwards 3 or forwards 3? Not just how far did you move, but how did you move in reference to where you were. So it's displacement. Therefore, you're talking integral d from 1 to 8. The second concept is they're wanting to use additivity. 1 to 8 is the integral from 1 to 3 plus 3 to 4 plus 4 to 7 plus 7 to 8. You just straight up add them. And so if you, forgive the lack of arguments there, but you're looking at what? 1, -6, -3? Okay, you understand? Now, if they had asked for distance, then I would have taken the positive of all those. Actually, that wouldn't have been possible. No. B, particles x, what's the position at time 7? Position at time 7 is x at 7. Wouldn't I need to take into account where they started me, which is x at time 3, and then talk the change in position from time 3 to time 7. Start plus change, position gives me ending position is the idea. They tell you at time 3, x is 3. And by additivity again, that integral from 3 to 7 is the same as from 3 to 4 plus 4 to 7. So you're looking at something like 3 plus 5 minus 7 or 1. You follow? Okay. 6. Question on 6. Use Newton's method to approximate f of x equals x cubed plus x minus 1. Did I change the directions a little bit, or did I not say anything and it's still 10 decimal places? Okay, so I didn't change it. All right. So this question might be, what do you want me to do? There's 10 decimal places. That's not in my notes. What are you talking about? So I apologize. Let's show you what I'm looking for. First of all, you could use either an initial of 0 or 1 because that's where the 0 lies. So what did you use? Whoever asked this question, did you use 0? One? Okay.
One nation, under God, indivisible, with liberty and justice for all.
Okay. So then,
Colorado Christian University from Lakewood will be counseling today during 7 hours. CCU has no classes on Fridays. All housing is apartment style, and the average class size is 13 to 1. Want to know more? Stop by counseling and sign up at the college physical level.
okay. I'll tell you what.
Very important meeting for 8 through 11.
I'll try and get better directions in the future, but let's just do one iteration by hand and we'll call it good. If you, the calculator component will practice. Sorry. So one iteration by hand would be this.
Today at 2:45 in the auditorium. No preparation is necessary. All junior hires are welcome.
Move up the data.
So maybe
On Thursday, 37 hours.
3/4.
$1.
Follow? Okay.
That's all your announcements. Have a great day.
Actually, maybe we have time because they're not yapping here. All right. So to do this in your calculator, then, is that the question? What do you want me to do in your calculator? Okay. So you would. Okay. So you would start by plugging the function into F1. So x cubed plus x minus 1, and then the derivative in x2, so 3x, or f2, excuse me, 3x squared plus 1. You follow? All right. In your home screen, then, you start the ball rolling by starting with your initial. We said let 1 be stored to x, okay? So I stored my initial guess to x and hit enter. Now I type in Newton's method, which is to say x minus the function at x divided by the derivative, which is f2 at x. Don't hit enter yet. Now you want to say store that over the old x and to it, make it a new x. Now the minute you hit that once, that's your first iteration. x1 is 3/4. Are we cool? x1 is 3/4. Now in terms of the work, I'll try and give you better directions in the future, but I want at least one Newton's method, and then in the future, let's practice. I'll say, give me 3 iterations. Okay, that's a typical example. So if I hit enter one more time and then one more time, then the second is 5986, and the third is 523,407 over 767,077. That's kind of what I'll do in the future. Say do 3 iterations instead of this 9 decimal stuff. Does that make more sense? All right. 6 check. 22. Question on 22. Okay, 22 is, so you've got y equals e to the x. And some horizontal line y equals k. Making an area with the y-axis, really cool?
Yes.
So the area is a function of k. The question is, did you use x or y? I don't care which. Did you use slices this way, which would be one integral, or horizontally, which is one integral? X, okay. So if I go here, then it's gonna, I'll get to the limits in a second, but wouldn't you agree the upper is k and the lower is the curve, dx thick? The limits of integration are 0 here. This would be where e to the x equals k, which seems like if I take the log of both sides, would be x's log of k. That's probably the hardest part for a, is what's the upper limit. You with me? If I integrate that, then the antiderivative is kx minus e to the x from 0 to log of k. That's k log k minus e to the log k. Darn it. Does that get you started? All right, well, there's always some period. Do your best. That should get you started. I get k log of k minus k plus 1 is the region. Without k, that's the best you're going to do. That should help you get started on B and C.
There's a B and C.
Yeah. The hardest part is it.
And I wrote it all just one time.
Lori, I'm always happy to see you this is Alright, what is today? 13? 12? You're welcome.